This is where we had reached in our previous video. We worked out the tangent plane equation to this problem that we had. Oh boy. Now, here we want to find the normal line equations. Alright? We're going to have them in parametric forms. Let's do it over here. Let me copy. Oh, we don't have to copy it. But before we do that, remember, as I told you earlier, the general format, delta, if we say f is a function of x, y, z, the general format, delta f by delta x, x minus x naught, plus delta f by delta y, y minus y naught, plus delta f by delta z, z minus z naught. Alright? Now, here, if we should do it like this, right? What we would have is 7x squared minus 8xy, 7x squared minus 8xy, plus 16y cubed, equals z. But then if we group everything together in that format, oh, by the way, hold on, I should put 0, right? If you group everything, we'd have to say minus z equals 0, right? For delta f by delta x, it would be 14x minus 8y, alright? What would be delta f by delta y? It would be negative 8x plus 48 y squared, which we did before. Pardon the coughing and so on, and the voice. I got the flu over the past few days, still trying to recover, right? What about delta f by delta z? Well, this would be negative 1. Remember, this would be negative z to the 1. When you multiply, bring down the 1 in front using the power rule. And then you say the whole power minus 1, you get 0. Alright? So it's 1 multiplied by negative z to the 0, but negative z to the 0 is negative 1. But 1 times negative 1 is negative 1. So you will have delta f by delta z as negative 1. Alright? So you see that? Now, the parametric forms of the normal line. You have, it's going to be y equal delta f by delta y of t plus y naught is in the similar form as y equal m, which is a gradient of x, in this case t, plus c. Alright? X equals, well, I should put x first. Let me put x first. Let me drag down all of this to make space to put x first. X equal delta f by delta x t plus x naught, and then z equal delta f by delta z t plus z naught. Alright? Now, delta f by delta t x, we worked it out already. Found that delta f by delta x was this. And at x naught, when you substitute x naught in and y naught into it, is 94. Alright? It's a matter of putting x is 5 and y at negative 3. And when you work it out, 14 by 5 minus 8 by 3, you get 94. Alright? Remember that. So x equals 94t plus x naught. What was it? 5? Yeah. Then y equals, we did it for y as well. We worked out delta y by delta x, and it was what? When we substituted, it was 392. So we have 392t was minus 3. Was it that? So let's check if my memory serves me right. Yeah, plus negative 3. And the z part now, z is equal to, as we saw before, it would be negative 1 t plus z naught. What was z naught again? Negative 137 is minus 137. Alright? You could just raise this and say negative t minus 137. These are the parametric equation of the normal line. We could eliminate the parameter after. In the first one, if we transpose for t, we get t is equal to x minus 5 over 94, right? In the second one with y, we transpose for t and we get t is equal to y plus 3 over 392. In the third one, if we transpose for t, we're going to get, well, first we get negative t is equal to z plus 137. And then when we multiply both sides by negative 1, we get a positive t is equal to negative z minus 137, right? No, t is equal to t is equal to t. So we could say x minus 5 over 94 is equal to y plus 3 over 392 is equal to negative z minus 137. Alright? So this is what we have. And if you wanted to, you could even multiply